Hello everybody and welcome to GenQA's December webinar, where this time we are focusing on improving the nomenclature for cytogenomics and what is new in ISCN 2024. And we have a large number of people registered for this webinar, which we're really delighted with. And just so you know, if you miss any of the webinar or if you need to catch up with it later, the webinar will be recorded and available to you shortly after the webinar. If any of your colleagues haven't registered for this webinar, the webinar will also be available on YouTube probably after Christmas, so other people can access it freely there. If you have a question during the webinar, please use the question box, type your question in there. We'll see how we get on with the questions. With a large number of people, we might not be able to answer all of them, but we will certainly get back to you with those questions. So it's my pleasure to introduce Dr. Ros Hastings, who is a GenQA consultant and the ISCN Standing Committee Chair. She's going to present on the restructured and revised ISCN 2024. Thank you, Ros.
Thank you, Melody, and thank you for the introduction. Good morning, good afternoon, good evening, depending where you are in the world. My name is Ros Hastings, as Melody has just said, and I'm going to talk about improving the changes we've made to ISCN 2024. This came about because quite a few members of the ISCN Standing Committee are on different countries' external quality assessment or proficiency testing providers, and have noticed problems with people submitting ISCN for the EQAs or the PT programs. And as a consequence, we've looked and reviewed the whole of the ISCN, found there was some historic information that shouldn't really be there, wasn't needed any longer, and other things where the rules were not clear. And also that many of the rules were in the middle of examples, and we've tried to pull all of these out. So if you've already got the book, you'll have noticed you won't recognize the chapters. But if you haven't got the book, you can go online, obviously, and see it now if you're already registered. And you will notice there's quite a few changes, but bear with us. It will be difficult initially as you get used to it, but having worked on this for 18 months, I'm much more familiar with it, and I'm sure you will in due course. So just to explain, there is a potential conflict of interest because I am the GenQA consultant and also the ISCN standing chair. And so obviously both of them are interested in ISCN, but it is in all cases for the benefit of the genomics community. So technically there isn't a conflict, but I just want to mention it just in case individuals perceive it differently. Right, I'm going to talk about the GenQA background and then the ISCN background and why it's needed, and then what's changed for 2024 and some of the educational tools that are provided that will help you, that are available on GenQA, but they're open to other people if you're not participating in GenQA. And then there is a quiz going through this talk, and there's also a quiz at the end, and if there's time at the end we'll finish with a further quiz. So just to give you a bit of background about GenQA in case you haven't heard of us, we are an external quality assessment provider, part of UK NEQAS consortium. It's a charity, it's self-funding, not for profit. Excuse me. There are 25 specialist centres with over 50 years of experience, and we are GenQA is ISO accredited under the ISO standard 17043, which is a standard for EQA providers, which is an international standard. And on this map, you can see that we have all the pink countries are GenQA member countries. There are additional UK NEQAS countries, and there are also some non-member countries, which you can see are very few and far between. And we have over 2,000 participating countries, over 200 expert advisors. We offer more than 122 EQAs, and we have 92 countries that participate. So we are a worldwide EQA provider, and we include an ISCN EQA. So these are the different specialities which we cover, and we also cover an individual competency for ISCN, which is new, as well as an EQA for ISCN. So feedback to the participants, if you're doing an EQA, you get an individual laboratory report such as this. And with the comments that are specific to the laboratory, there's a specific summary report for each EQA which details how participants did and includes benchmarking. And then there's a certificate which is a performance certificate of how well you did, whether it was poor, satisfactory, or you're just enrolled and didn't actually submit across all the EQAs that you registered for. And you can review all these as an EQ, as a department, as a learning exercise and to improve your diagnostic service. EQA, although when you get these reports, you sometimes are a bit either frustrated because you made a simple error or that you're irritated by some of the comments that are made, but the idea and the aim is always to be educational so that you can improve your diagnostic service. And we do now have individual competency modules, which I would call Genie, which I will talk about at the end of this talk. So first question, I'm not going to do a poll, just think about it. What percentage of the laboratories that submitted the correct ISCN for the GenQA Microarray ISCN last year in 2023, what proportion do you think it is? Just have a quick look at the numbers. So what do you think it is? Well, the answer is 37%. So why do we need nomenclature? I hope I don't have to convince you because I hope you're already using it, whether it's HGVS or ISCN. And it's a requirement for accurate reporting of results, accurate interpretation by clinicians, and so that the results can be transferable and understood by different healthcare providers, and also enables clear communication of the results in publications and therefore the advancement of knowledge and new conditions, as well as consistency for database entries. So when do you use ISCN and when do you use HGVS? Well, ISCN is used to describe variants at a chromosome or gene level and includes numerical changes, structural abnormalities, pathogenic variants such as CMVs, haplotypes and repeat expansions. And it would include deletions, duplications, insertions, inversions, translocations, etc., etc. And it describes what the abnormality that is seen. So if you've got, as a simple example, trisomy 21, you put ×3. In HGVS, it's used to describe DNA, RNA, protein sequence variants at a gene, nucleotide, amino acid level. So it's at much higher resolution and includes frame shift, missense, nonsense, insertion, deletion, duplication, tandem repeats, and SVs. But the difference between HGVS and ISCN is it describes a change on one DNA strand chromosome compared to the reference sequence. So if you had trisomy 21, it would be written down as ×2. And that is a fundamental change between the two. So looking at HGVS for a minute, what percentage of papers submitted to Research with Genetics in Medicine journal do you think had the correct HGVS nomenclature? Do you think it's 80%, 35, 5, 94, 65? It was actually 5%, which is not a high proportion, to put it mildly. One would expect it to be, if not similar to ISCN, but actually better. Anyway, that's what the results were. So let's look at the ISCN Standing Committee. There are 9 members. This is a picture of all of us at the last meeting we had, which was just over a year ago. We're all volunteers elected by the genetics community, so we get no payment for this. We do get a free copy of the book, but that is all. And we're part of the Hugo Standards Committee. Now, this is the latest version of ISCN. There is an online version which is available now and has updates. And what is different this time is if you have the hard copy, again, the code is in the inside page for the online version, and it is available for 4 years. You've got access for 4 years, which is an improvement from last year. And this is what the new website looks like, and it was released on the 4th of November, and you sign in here. And then you can see the different previous editions and the latest edition. You see 2020 is now an Informa edition, and there's other things like HGVS here. But the thing I want to concentrate is on the forum, because a lot of people don't seem to be aware of the forum where you can ask questions or say there are errors in the ISCN that we need to address. So please do go in there and use it. So you can, when you go in, you can see all the previous questions, you can add a new topic, or you can respond to some of the questions that have already been put there. So ISCN is used for karyotyping for fish, for RSA, array, genome mapping and sequencing. And what we've done in ISCN 2024 is we've done a big restructure. So we try to put all the generic rules in chapter 4, that the specific technique rules are in the relevant chapter. So there is a bit of duplication there. The ISCN examples are now numbered, so you can easily, when you're talking to other people, refer to the specific example instead of having to count it on the page, and the rules are all numbered. There are additional nomenclature examples in the book. The RSA region-specific assay has been expanded to include targeted chromosome analysis, targeted microarray analysis, both of which were requested by the genomics community, fusion genes so that it was consistent with the rest of the nomenclature, expansion repeats was requested, as was a methylation assay for imprinting. Plus we have a new chapter on genomic mapping, and the ideograms, I've already had this question fully enough on the forum, are in the appendix at the end. So they're not at the beginning of the book, they're right at the end of the book. We've used the Genome Bill GRCH38 throughout for band designations and nucleotides, and we've tried to streamline the nomenclature so there's consistency across the different technologies. There's probably a bit of room still for improvement on that, but hopefully you will understand why we've made some changes to the rules. So these are all the chapters. There were 20 chapters in ISCN 2020. We've amalgamated quite a few chapters, and there are now only 16 chapters. The ones in pink are the ones we've changed. So we've condensed the historical introduction. The normal chromosomes now incorporates part of chromosome 7. General new rules now incorporates 4, 5, 6 and part of 8. The numerical and structural abnormalities incorporates the rest of chapter 8. Genome mapping, chapter 9, is a new chapter, and the region-specific assays now includes targeted analysis, and the appendix includes the ideograms, and that should be an I. So just to show you, these are the new examples in each of the chapters, and you can see there's quite an increase in the number of examples we've given. Excuse me. So the biggest change is spaces. So some things haven't changed. There's no space except there's now a space between the technique, genome build used, and the results. So this is new. Before, where there was a bracket, you didn't put a space. Now we've made it consistent. So there's no change here. There is no space between, say, hemizygous, but there is still a space between homozygous and uniparental disomy. There is still a space between the two symbols, for instance, pseudo-dicentric, and there's a space before and after con, sep, or mos, or chi. So there is now no space before mat, pat, de novo, etc. after a copy number. So it's this one here that has changed. So the other thing we've done is try to make it a bit easier, although when you first see this, you probably won't think it is easier. And that is we've tried to describe the two different formats that are used in ISCN, which are dependent on the technique used and the structural information given by the assay. Now, some assays give both, and so it's your choice which you use. So if you're using the karyotype format, that's for banded analysis. It's for in situ hybridization, genome mapping if you can work out the structure, sequencing if you can work out the structure, and some region-specific assays, again, if you can work out the structure. And there's an abbreviated form, a short form, and a detailed form. The short and detailed forms are exactly the same as you would have in ISCN 2020, and the abbreviated form is for numeration of fish probes, and this is an example here with ISH7. So it's a very short ISCN. The microarray format is for the molecular cytogenomic techniques such as microarray, some genome mapping where you only actually get the microarray information, sequencing, and some region-specific assays. And again, it's abbreviated, short, and extended systems, exactly the same as ISCN 2020. And it's just a reminder, we've made it clear in the book and the online version now that abbreviations of Peter and Q2 are not used in the microarray format. And these are just examples of the abbreviated format. The short format, which is basically the nucleotides spanning the where the loss has occurred, and the extended, where you have the last known normal copy of the region. When it comes to karyotyping, we've put some extra clarification, which hopefully will help you. We put all the ISCN structural chromosome examples into one chapter. They were over 3 chapters before. When you have this mosaicism, occasionally you get the same cell numbers and you do not know what the order in which to put the cell lines is. It was never very clear in the ISCN book, and we've now applied a sequentially rules that you would apply sequentially. And the other change we've made, because again we had feedback from the genomics community that a question mark meant perhaps you didn't know if there was an X there. So if you've got an undisclosed sex, you now put 46, U, and the U replaces XX or XY. And for neoplasia, again, what you do when you've got clones of the same complexity, and again, we've put some rules which are exactly the same as for constitutional, which you sequentially apply. There was also feedback from the forum and from several meetings where we've described ISCN as to what do we do now when we've got chromosome band resolution on a karyotype. But if you look at WHO or other publications, the gene is known to be located at much higher resolution. Do we use the resolution where the gene is located, or do we use the chromosome band resolution? And it goes back to the principle, you write what you see. And so if you've got a 400 bands per haploid set, then you would put for an 821 translocation Q22, Q22. And if you did happen to have on a neoplasia sample 700 bands per haploid set, then you can put a much more specific band. So you do not adjust it to the gene location. We've also clarified the counting chromosome aberration table because there was some misunderstanding, and there was a publication about it where they hadn't understood the rules. So we've now corrected that, and also given some examples so that you can see how the rules are applied. There are more composite karyotype examples now, and there are some figures and again some helpful rules for when you have divergent clonal evolution and unrelated clonal evolution, and how to write the ISCN. So in the metaphase fish, again, this came out through an EQA, funnily enough from GenQA, where how do you write a tandem duplication versus a non-tandem duplication on the same chromosome? There is an example in the book with a tandem duplication, but there were no examples of a non-tandem, so we've now put that in. And if it's non-tandem, such in this example here, then again you write what you see. So it might have a whole chromosome paint, and then you've got 2 copies of the probe set. You do not put plus plus, because that's not telling you you've got 2 separate copies. Plus plus is telling you it's tandem. Also, when normal results are given, so that it's the same as for all probe sets, whether they're abnormal or normal, you now must separate them. You do not amalgamate them if they're different probe sets. So you write the results according to the probe sets. And as I said before, there's a space now here. We've removed the detail system for normal results, only using the short system. So this example has been removed, as have these. These stars, by the way, in this ISCN are not ISCN. It's just that if I'm talking about any of the examples, I have to make a comment about that they're published courtesy of Karga. So all the detail systems have been removed. We've also made it so it's consistent with RSA and the array nomenclature, so that the multiplication side is outside the brackets unless you've got different signal patterns. So this has become the ×2 outside the brackets, the KMT2A again outside the brackets, and you've now got a space after ish, and this one is exactly the same as before, when you've got 2 copies of ABL1 and 3 copies of BCR ABL. And also for the fusion genes and the break apart, again, the ×1 goes outside the bracket. So I think this is where I get a poll. So I'm going to launch it and you can answer it. It's a prenatal sample with a maternally inherited 1122 translocation, and they requested the undisclosed sex. What do you think the answer is? I've got 50% of you answering, so I'm going to close it now and see what the answer is. Yes, you're quite correct. Vast majority of you voted for this one. Well done. Next question. So you've got interface fish, you've got a normal result for ABL1 and BCR in 200 cells, which is the correct ISCN 2024. Right, most of you have said A, and you're correct. Well done. A few of you have put B. There should be a space here, and that's the only thing you're missing, and that's the change from 2020 to 2024. And the final question of this group is here. You've got interface fish again. You've got a normal result for the CLL pros ATM, D12Z3, D13S319, LAMP1 and TP53, which is the correct ISCN now in 2024. Right, half of you voted. Mixed result here. So we've got 50% with B, 33% with A, 11% with C, and 6% with D. And the result goes with the majority, which is B, and that's the change. Those of you that wrote A, that's ISCN 2020, but as I say, if you haven't got the book, you won't be familiar with it yet. Let's move on to the next slide. Right, one of the things we've done to improve consistency is we noticed if you've got a loss or a gain within the same break point, depending on whether it's a karyotype like ISCN you're using or an array like, it's slightly different. If it's a karyotype like, you have to put both breakpoints in, so it's Q22, Q22. If it's an array like, because you've got the nucleotides, you can tell from the nucleotides it's interstitial, so you only have to put the breakpoint once. And so obviously the genome mapping nomenclature, it's all new because that's all new nomenclature, but it does mean there wasn't an example for one of these in microarray format, and it's changed for the deletion. There wasn't an example of a duplication in ISCN 2020. So that's how we've got consistency, because you obviously from the array-like, sequence-like nomenclature, you can tell whether it's interstitial, but you have no idea. If you only put one breakpoint in the karyotype like that, would suggest a terminal deletion. Also, we've given examples. We try to be helpful. You may decide this is different to that, but anyway, we're aware that we are getting much more complex results than we ever did. And this is why perhaps in the future we have to look at other ways of writing our nomenclature, because they are getting more complex. And so for array, genome mapping and sequencing, we've tried to explain what it is you need to put. You have to put the chromosome and the band, the genome build, the genome coordinates, the abnormality, the type of abnormality, loss, gain, etc., and the proportion of the sample with the abnormality where that's applicable. So we've tabulated it so that you can see that this is an approach that you can use. Now, one of the feedback questions we had from the ASHG conference was, well, we can't put that in our reports because our computer software doesn't allow us to do that. But you could actually just write it in a sort of list form if that would help. But it's just to give you ideas of different ways of approach rather than doing a long string of ISCN. The other issue that came up, there's a terrible picture here from the book, where you've got a mixed population. So if you've got a mixed cell population, then the largest cell line, this is in Constitution, the largest cell line goes first, the normal cell line is always last, regardless of the size. And in Nukish, the normal is always in the denominator, except for sex chromosome determination, which again is in the book. So this is just an example in red where the sex determination, because this is the actual normal cell line, but it's also included in the denominator, and it's just so you know what the normal sex chromosome complement is, because it could be a difference if it was female or male. However, when you've got equal numbers of cells in the, say, 2 or 3 cell lines, then it's the following order that applies. So the XX cell line is listed before an XY when neither shows an abnormality. Where the abnormalities are in different clones or cell lines and involve chromosomes a different number, then the chromosome order rule applies. So X before Y before autosomes, an increasing number. When the same chromosome is involved, gains are listed before losses, before structural changes. And for structural abnormalities of same chromosome number are listed alphabetically. So an add is listed before a dupe, for instance. And when the same abnormality is detected on the same chromosome, the Peter to Cuta rule applies. So you apply it, depending what you've got, you apply this consistently. It's in the book, so you don't have to take photographs of this or anything because it's there. It's also online, of course. And for clones, in most situations, the least complex acquired clone that's listed first, and the normal cell is always listed last. If you've got a constitutional cell line, then the order is as follows: abnormal clones with a required abnormality, followed by cell lines with a constitutional abnormality, followed by the normal cell line if present. And so this is just an example here of an acquired loss of chromosome 21 in an individual with mosaic Down syndrome. However, where you've got equal complexity of the cell lines, then it's exactly the same sequential application of the rules. In post-transplant chimerism, the recipient is listed first, and when their abnormalities in different clones involve different chromosome number, the chromosome order rule applies, X before Y. And in the book, we've given examples for unrelated neoplastic clones and related neoplastic clones. And again, when the same chromosome is involved, gains before losses, structural abnormalities, same chromosome are listed alphabetically. And when it's on the same chromosome, the Peter to Cuta rule applies. So we've given you lots of examples, which I hope will help you in applying the rules. Also, when it comes to microarray, depending on your platform, you may not be able to get a precise quantification of the mixed cell population. Now, often you can give a range of copy numbers using the tilde, so that's no change like times 1 to 2 to ISCN 2020, but sometimes it cannot be determined. And so in the short form, it would be times greater than 2, because you know there's more than 2 copy numbers in if it's a gain, but you can't quantify it. And also sometimes with amplification, again, you can't enumerate the copy number, and so you use amp with a question mark. The other thing we've added is that in neoplastic samples, multiple clones, it's optional whether you include one when it's 100%. So if you've got multiple clones in the short system, you could say there's 0.5, 0.75, and 1, or you can not put the 1 in. It's perfectly optional. So it's exactly the same example, but not the 1 here. However, if this was in a different order, so the first, the 13q13.1 was in 100% of the population, then if you write it as in this one, just short form here, and you put 0.5 at the end, people could imply that this actually is at 50% when actually it's 100%. So in that particular instance, it would be helpful to put the 1. Please note that the proportion is not adjusted for tumor load. So other changes to the array ISCN, we've got a new acronym for uniparental disomy, detected molecularly, which is UMAT and UPAT. I mentioned the example of the tabulated array result. We've put chimera examples in because, again, we were asked how you write a chimera, and also complex array results using different types for chromoanagenesis, chromothripsis, and chromoanasynthesis. And we've also specified that if you have an abnormality involving the sex chromosomes, then you can put the normal Y and the normal X in there if it gives clarity to for the gender of the patient. In some cases, it doesn't make any difference, but where it adds clarity, then you can put it in, because usually what you do is you only report the abnormal results, but that's an exception. Also, for SNP arrays, you can use the symbols greater and less than n, 2n, 3n for the genome ploidy if it's in neoplasia, but you do not use it for constitutional. We've already mentioned UPAT and UMAT. Here are some chimera and complete mole examples. And here's an example of a neoplasia post-transplant chimerism. I'm not going to go into detail. You can look at this talk later, and you can also look at the book. So, next question. An array revealed paternal homozygosity for the long arm of chromosomes 15 and 21. Which is the correct ISCN 2024 for this result? Right, 55% of you have voted, and 5% thinks it's A, 23% thinks it's B, 3% thinks it's C, and 69% thinks it's D. And those that said D are quite correct. A is ISCN 2020, and there shouldn't be a space here for the B, which is the other one that was incorrect, and you need a U here. Right, to move on. The region-specific assays for 2024, we've added some new acronyms for the imprinting where you do a methylation nomenclature. And we've added MET for normal methylation, GOM for gain of methylation, and LOM for loss of methylation. And a normal result would look like this, where you give the copy number and the methylation. The methylation nomenclature is based on a paper that's previously been published and agreed with HGVS, and what was missing was the copy number, and so we've now put that in, so you've got both in the book. For an abnormal one, so this abnormal one is showing gain of methylation for the SNRPN allele and no normal paternal methylation for 15q11.2, q11.3, which will be consistent with Prader-Willi. We also have now targeted regional specific assay. This does not include fish. That's the one thing that is not included in this chapter. Fish is got a chapter of its own right. It is not part of the RSA nomenclature. And the targeted analysis describes normal and or abnormal results for a specific chromosome or region tested. And it now includes targeted chromosome analysis when the full chromosome analysis is not undertaken, or targeted microarray analysis where a specific chromosome or region is only analyzed. And so if we look at targeted chromosome analysis, then we are talking about for balanced structural chromosome complements where the homologs are apparently normal, then the abbreviated or short system can be used, which is analogous to full karyotyping. The short system includes the breakpoints, whereas the abbreviated system does not. However, if there is a non-rearranged homolog that is lost, then the short system nomenclature should be used, and the number of normal homologs should be described as 0. Again, this is all in the book and online, so you'll be able to see it there in more detail and be able to look at it and think it through. Plus, you can look at this talk afterwards. When you have a numerical or structural abnormality, the unbalanced chromosome complements are always described in the short system, where the normal chromosomes are listed in the ISCN. And for mosaics, it would look like this. So hopefully when you're doing a very specific screen, this will help you with your nomenclature. If you're doing a full karyotype analysis and a screen, you will need to put both the karyotype and the RSA in to your ISCN. For targeted array, you are using the same array nomenclature, but you are using the term RSA, not array in the ISCN, because you're only looking at a specific chromosome and you're not doing a full genome analysis. So for a normal target array analysis for the whole of chromosome 22, you'd put RSA 22 times 2. for a normal result if you were just looking at a specific area like Digeorge, then you would put in, use short form and put the breakpoints and the nucleotides. For an abnormal result, you can do the abbreviated short or the extended system, and this is an example for the loss of the Digeorge critical region, deletion syndrome region. So the fusion gene nomenclature has also changed. So now we do it so it's more consistent with the fish and the RSA nomenclature, whereby before this we had positive and negative, and being as EQA and PT providers are always telling participants not to use positive and negative, it was quite ironic that ISCN used positive and negative. So we've changed this, and so this is now ABLE1, BCR times 2. This also fits in with the paper of Bruford et al. And in this case, for a normal result, the numerical order rule applies. When it comes to abnormal and you've got a fusion product, you use the double colon, and it's the active oncogene fusion that is listed. So that's BCR ABLE. So that's why it's the reverse order. So when we're looking at sequence ISCN, we've tried to clarify the terminology, and we've given examples in the ISCN for the different platforms and bioinformatic algorithms. There are more, There are more complex examples in the sequence chapters that have been added, and we've added normal and aneuploidy examples, plus some mosaic examples. And the description also informs you that whether you need to just use both ISCN and HGBS, or either can be used, or that ISCN is more informative than HGBS, and therefore only that needs to be used. So we've tried to explain when you need to do both. I think when you've read the chapter and you've read the examples, you'll understand where we're coming from and when you need to use both and when you don't. For examples where ISCN is more informative are when you've got inheritance from a parental rearrangement. HGBS doesn't give you that information at all, and therefore, provided you can get the structural abnormality information, ISCN is much more informative. And again, the one change I mentioned earlier is sequencing is now the same as array, where if it's the same breakpoint loss or gain, it's only listed once in the ISCN portion of the nomenclature, because you can work it out from the nucleotides. So when it comes to normal results and aneuploidy, then if it's normal result, you'd write sequence, have a space, X, comma, for a female this is, 1 to 22 times 2. If you had aneuploidy, and I'm just using an example here of, say, 1X, the easy cytogenetic answer is to write this. And this is a case where you can use either. They both give exactly the same information. I would probably argue this is the ISCN is a little bit more informative, because in HGBS, because you have to go against a reference sequence, it doesn't tell you whether it's an X or a Y that's been lost. And if you had to write that out on your reports, I think most of you would probably choose to use sequence open brackets X, close brackets times 1. So next question. For a targeted chromosome analysis for only chromosome 21, mosaic non-disjunction, you had a mosaic non-disjunctional trisomy 21 in 10 out of 30 metaphases. Which do you think would be the correct targeted chromosome analysis ISCN for 2024? Now, I appreciate I went through those slides very, very quickly, but do have a go at working out which you think is the correct result. And again, half of you, more than half of you voted, and we've got 6% choosing A, 10% choosing B, 20% choosing C, and 64% choosing D. And the answer is D. Well done. So just to give you an explanation, denominator is not used in, it's only used in Nukish. It's the only time it's used. It's not used in RSA. In this particular case, the normal cell line should always be listed last, and this is targeted microarray analysis, and this is targeted chromosome analysis. So the next question, analysis of the 22q11.2 deletion syndrome region, where you've got loss of one copy using genome mapping, which is again, it's a targeted assay, which is the incorrect ISCN, sorry, get this right, which is the incorrect ISCN 2024 for this result. Right, we've got over 50% voted. 4% have said A, 69% have said B, 9% have said C, and 18% D. And it is B, you're correct. This is incorrect because this implies the whole of the chromosome 22 was analysed. The other three options are all correct. One is A is an abbreviated form, C is the short form, and D is the extended form. So, genome mapping. We published a paper at the end of 2023. But just to give you a bit of background, we started looking at this nomenclature. It actually got raised as a question to the committee on the 28th of September in 2021. We had 3 examples then. By August 2023, when we actually started getting to publish this paper, we had 81 examples, and they are in the book. So you will notice it is very similar to RSA and array nomenclature, and constitutional and neoplasia genome mapping are exactly the same. So for a normal result, whether it's female as the first example or male, or where the sex is not disclosed, exactly the same for array. You don't use U because you just exclude the X and the Y from the analysis. And for aneuploidy, and here's an example here of an XYY trisomy 8 and a trisomy 21, you can put the 8 and 21 in the same bracket. Sorry, I'll go back a slide. So we've also got examples in the online and in the book of deletions, duplications, insertions, inversions, translocations, and complex results. Again, you can use the karyotype or the microarray formats. The karyotype format is used if the structural nature of the abnormality is apparent, and then you do not add the copy number. So if you use the microarray format, then you do give the copy number. And again, you've got the abbreviated system, which is in the microarray format. You've got the short system in the karyotype format and the microarray format, one which includes the copy number, because the copy number is included when you include the nucleotides, and it's just the chromosome breakpoints, whereas the short system, the karyotype format, defines the structural abnormality. The abbreviated system is used for aneuploidy and chromoanagenesis, and only the chromosome is given, no nucleotides. And then the details system, again, you've got the span of the structural abnormalities for the extended system in the microarray format, as well as the flanking uninvolved nucleotides, and then commas are not used because it just becomes impossible to work out where the copy number is if you do that. Whereas the detail system, the karyotype format, describes the abnormal chromosomes in their entirety from Peter to Q. If you've got a derivative chromosome, it's not necessary to include the terms del, dup, ind, insertion T, because the structure is apparent from the nucleotide coordinate sequence, but you don't include the copy number. Again, this is all in the book, so it should be clear, and in the paper if you've read it. So in genome mapping, you give the platform, labeling strategy, bioinformatics, pipeline in the narrative, not in the ISCN. Multiple abnormalities can be presented in the table. There are examples in the book, and only the clinically relevant abnormal results are given. Normal sex chromosomes may be reported for the purpose of sex determination. And again, for all, as in all other examples, aberrations are listed in numerical order, band designations and aberrant nucleotides are listed P to Q, and multiple structural changes of homologous chromosomes are presented, with the abnormality closer to Peter being described first. The VAF, the variant allele frequency, can be given in ISCN. That's a change from the published paper. It's now in the ISCN because we had feedback and we decided to include it. And the nucleotides indicate the extent of the fragment determined by the positions of the labeled DNA motif within the variant region. So they're not necessarily those are the actual breakpoints, and that's a limitation of the test. This is an example of a deletion, so you can do it three ways. This is the array type nomenclature, where you've got ×1. This is the extended, where you've got the normal flanking nucleotides, and this is where you describe it as a del because you're using the karyotype format and there's no copy number. If it was Mosaic and Constitution, you could put C after it and the 0.5. And a three-way for a fusion, and this again is using the karyotype format because you can see it. This is just showing you the 21, 12, and 6 genome mapping image. It hasn't shown you all the other chromosomes. You've got 6, 12, 21. These are the breakpoints. And then you describe the area in which that breakpoint on chromosome 6 may have occurred, the area in which it's happened on 12, and then 21. And then you describe, it's optional again, the resulting ETV6 RUNX-X1 fusion and the variant allele frequency. Inversions, they may appear identical to translocations between homologs. So you could write it in these two ways with an inversion as P13.11, Q11.2, and then the range, or you could write it as translocation because you don't know which of those two options it is, or alternatively, you could write it without giving the mechanism, which is to put 16, 16 together. That is a specific nomenclature that we've developed because the mechanism is not a paramount of a technology, doesn't allow homologous chromosomes to be distinguished, in this case chromosome 16. And for a ring chromosome, very like karyotyping format, where you've got the ring and then you've got the 2 colons means you've got break and a join. And when you've got uncertain breakpoints, you just put a tilde between the breakpoints and the underscore. So, a couple of last questions for you. Normal female result using genome mapping. What's the correct result using ISCN 2024? Remember, it's very like array. Right, I'm going to close it because the vast majority you've got this right. And it's exactly the same as array. Just remember there's a space after OGM abbreviation. Next question. You've got an interstitial deletion of 17q11.2. What's the correct result for this? This is quite hard, right? 50% of you voted. Most think it's A, 49%, 28% think it's B, 18% think it's D, and 4% think it's C. And it is A. Well done. You could also obviously put del 17, and the reason why the bottom one is wrong, D, is because you put ×1. There shouldn't be 1. C is wrong because you need the ×1 in it, and B is wrong because you need both breakpoints because it's karyotype like. I think this is a ring chromosome 8, which is the correct ISCN for this one. I'm going to close this. That's half of you have voted. 68% think it's A, 23% think it's B, and 5 and 4% think it's C and D. And again, the majority of you got it right. Well done. The second one, you've got a structural rearrangement, and you've got ×1. You don't include that for genome mapping. For C, you're missing the break and join double colon, and you don't include ×1. And again, for D, you're missing the double colon. So we've gone through all of this. Now, you're going to get the book. If you haven't got it already, you can go online and see it if you've already paid your subscriptions. However, there's quite a few changes. And yes, we've done this seminar, but there are other things you can do. So if you've got questions about the ISCN, please use the forum. We don't necessarily all answer within 24 hours because obviously we have day jobs, but we will get back to you. If you've got HGVS questions, please use the HGVS forum. Do not use the ISCN forum. There are many EQA and proficiency testing programs, national and international, that provide ISCN in their assessments. Some providers such as GenQA also have a specific ISCN EQA, and there are plenty of publications. We're hoping to publish a brief paper on the changes, which will also help people. And there's also an individual competency modular system called Genie, which is provided through GenQA. And the ISCN module has just been released, as has an HGVS module. There are also webinars. So there was an earlier webinar of the changes for the ASHG last year, which is online and you can pay for. And this webinar will be available free and on the YouTube free. There are also workshops that GenQA offer. I'm not aware if any other EQA provider does that, but check with your EQA provider if you don't use GenQA. And just to show you why EQA is important, this is just to show you that this, the first set of columns are for the different aspects of ISCN, and this is over 2020 to 21, 22, 23, and to show that there has been a marked improvement in the number of correct results and a reduction in the number of critical errors across the board. There are a few areas where it's just the same, or the numbers are so small that a slight change makes a difference. In addition, I've talked about the online training and competency tool called Genie, which is for individuals. It's not for labs, so it's an individual. A lab can sign up multiple individuals, but it's on an individual area, and you can select the area of genomics where evidence of competency is needed. As I say, it's modular, and we've got variants, so you can do variant classification for SNV and CNVs, and you can do HGVS and ISCN nomenclature, and it enables all staff involved in the medical genomics services to showcase their expertise, and more information is available on the GenQA website. And just to give you some information, there are these videos on different aspects of a genomic medicine that are covered on Genie. There's BRCA1, BRCA2 and HRR genome variant classification. There's HRR variant classification. There's SNV classification and CNV classification, and ISCN nomenclature and HGVS nomenclature. I haven't got time to do the video. Oops, I'm going to move on. Because we're running out of time, but when you get this talk, you can look at this video and see a bit more about it. And just to show you what the ISCN module looks like, you'll get a case. This is one for constitutional karyotyping, where you get a written description, you get an image, and then you get several options, and you have to describe the correct option. That trial opened on the 4th of November, and these are the sort of results that we get. We're still getting a lot of incorrect results, but we are seeing improvement, and you can do it multiple times to improve your competency. And these are just showing some of the errors that were made and were submitted. And HGVS is exactly the same. You get given the gene, the reference sequence, told what the abnormality is, and you have to describe the correct nomenclature. No sooner have you done it, I did it a couple of weeks back, and you get the certificate straight away. You also got the SV classification, where you get the variant, the mode of inheritance, zygosity, referral reason, testing, date classified, guidelines, and you're asked to then select which classification it is, and then to select the variant, the relevant criteria, and the evidence you have used to get that classification. And when you get feedback on what the expected answer is. And this is sort of certificate you get. And this is some feedback on the Karyotyping ISCN, and you get feedback about what your answer is, an expected answer. If you get it wrong, it tells you why it's wrong and on what the correct ISCN is. So you learn from the whole procedure. And just to, again, to keep up to date, we have newsletters. There's plenty of information on the website. You can join Twitter, LinkedIn, or go on to the YouTube. So there's plenty of places where you can get more information should you need it. So I'm aware time is running out. I'm not going to do the quiz because we do not have time. And it's just quick thank you to everybody for listening. I hope you enjoyed it and that you found it helpful. But please use the forum, obviously by subscribe to the website or buy the book or do both. And we look forward to hearing from you in due course. And I can't have done this talk without acknowledging, first of all, the ISCN Standing Committee, the genetics community for all the suggestions. We had hundreds. Bionano for that, for the ring and the 61222 circus plots, Karga Publishing for the online ISCN and forum, and then GenQA for the EQA and GD data, and the JANCA staff, obviously, who've also helped to do this webinar. Thank you for listening.
Thank you, Ros. That was a very detailed and informative presentation. As you mentioned, anybody who's missed it or wants to go back to a particular section, the recording will be available for you. So we are slightly over time. We've got a couple of questions I think we can answer quickly, and then we had over 700 people register for this webinar, so there are some questions that we'll get back to you by email. So a very quick one was somebody's asked when ISCN 2024 will be a requirement for GenQA, so for the assessments. So we understand that laboratories need to transition to the new standards. So we usually give 6 months for you to do that. So the EQAs will be marked according to ISCN 2024 from May 2025. So in the meantime, we'll give feedback of what the correct answer would be in ISCN 2024, but you wouldn't receive a deduction.
And the only thing I'd add to that is if anyone's doing professional exams, get in touch with your professional examination board and ask them when they're going to start using ISCN 2024. Because we can tell you what GenQAs do, but we can't tell you about examination boards.
That's right. I also thought listeners might be interested to know that the basic constitutional ISCN module is actually free at the moment. So it'll be free for you to have a go at that until the beginning of January. So if you have a look on the GenQA website and look at the Genie section, it will show you how to register for that. So you can try that out for free. And then just a quick ISCN question that I think is quite interesting. So you mentioned right at the beginning, Ros, that Peter and Cuta are not allowed in array nomenclature, but they
Correct.
are acceptable in OGM and sequencing.
Yes, that is correct. We know that's a slight discrepancy, but the difference being that with those platforms, you with sequencing, HGVS puts it in, where even though they may not know what the endpoint is using sequencing, and in genomic mapping, you can usually work out whether it's towards the end of the chromosome, whereas in an array, you haven't got that information, and the committee decided that they felt it was better not to allow Peter to Cuta in array because it implied that you knew there was definitely a terminal deletion when you don't.
Yeah,
because
there's a
got
bit more
repeat
coverage. And
you don't know, but there's better coverage in sequencing and even in the OGM.
okay, we'll just do what else have we got?
The basic reason behind it is trying not to overinterpret data and trying to take away things where it could be overinterpreted.
Yeah. Thank you. And one more quick one. So in the OGM nomenclature, is that updated in, for example, the Bionano software? Because probably labs might be copying and pasting from the software onto their reports. Are you aware of that, Ros, or is that something they need to contact the particular manufacturer?
I think they need to check with Bionano. Bionano have been aware of ISCN 2024. They've also been aware of the changes and the nomenclature that we made, and so the latest version should have included it because I went through it with them and picked up errors that they had in their previous software. But you will have to check with them. I haven't actually spoken to them when I last was at the last meeting.
Okay, thank you. So yeah, so there's a few more questions which we'll respond to individually by email. And as Ros mentioned, if you do have particular ISCN questions, that online forum is available for you to ask your ask the experts about your ISCN questions. I'd also just finally like to acknowledge there was a one of the questions, I think it was one of the poll questions where there was only one incorrect answer. There was a bracket missing from the question on the poll. So apologies for that if that confused anybody. That's our error, but hopefully the explanation provided allowed you to understand what the error was there. Great, so thank you for listening, everybody. So we do appreciate your feedback on these webinars. So you'll be sent a survey by email following the webinar for you to give us your feedback, and that would be much appreciated. You will get a participation certificate if you joined the webinar live in the next day or two. And as Rosa said, if you want to keep up to date with GenQA activities, please register for the newsletter. And to finish this off, just to say that our next webinar, the topic will be the NHS Generation Study, and that will be held on the 4th of February. Details for how to register that will be on our website shortly. Thank you very much for listening.
Thank you.